I pulled this slide off of the Nevada Department of Public Safety. This is field of vision. And I did slight modifications to it. So a field of vision is the entire area that you can see while looking straight ahead. You have your center vision, which is specifically targeting. That's this narrow line here off the center of the car. And that's, I believe they said 10 degrees center vision. And in my opinion, this is why when they hang traffic lights on the booms across the road, they put a box over each independent lane. It's because they want you to target your vision directly on there. They don't want you to deviate too much to the right or left. Next, we have fringe vision. That allows for depth and positioning of the vehicles moving around you. This is kind of us sitting in traffic all flowing the same direction, but again, when you get into wider roads, you're probably going to have another set of lanes going the opposite direction. And then we have peripheral vision, color and motion. So when a vehicle passes over here, you're probably just going to see a blur or something. You're not going to be able to read the license plate, or you probably even see who's in the car, just kind of a motion moving. Now, this is what I wanted to show you here. I wish they would have put this in here. If you are driving that yellow car in the direct center here, I want you to pay attention to this car here with the yellow X. So you're driving. If your car sits lower than this car here at the yellow X, let's say this is an SUV and this is just a four-door sedan, the area between these lines, and this is just an estimate, and you're constantly moving forward, would most likely be blacked out, meaning you would have no vision of what's going on to the left side here. You might pick up hints of what's going on, but you're going to have that view obstructed with however that car is positioned in the lanes next to you. And then again, I put this additional lane here. Let me pull these off. I went ahead and put the additional lane and the additional yellow car to try to give you a sample of the wider your road, the more peripheral vision you have on what's going on in the furthest lane over here. So let's say you're driving along, there's a bus coming down here to come to a stop. It goes past your fringe vision, you're probably going to have about 30 feet to not really see what it's doing because, again, you're driving in your heavy flows of traffic and you want to keep your vision, your central vision, targeting forward to make sure you don't hit a vehicle in front of you. Here is another slide, the three visual fields. It gives kind of a three-dimensional idea of how your vision works. Central vision, again, visual acuity, targeting signs and signals. And if you look at your eyes, you're pretty much trying to focus that straight on. And you can see how fringe works off of that, referencing and path of travel. And then finally, peripheral vision, motion, and color changes. Now, I thought this was interesting because it also shows there's kind of a downward view when you, if you're looking straight ahead, your fringing or peripheral are going to kind of have a downward tilt for what you're seeing. And you're going to be driving your car. You probably have a roof on the car, so you're not going to be able to see too far ahead or too far up on here. But another thing I want to point out are the signal light positions of a school bus. If you are driving forward on a school bus in a vehicle, most likely you're sitting halfway down from the height of the bus itself. Those amber signal lights are positioned high up. So there's a point where you're approaching the bus or coming up from behind the bus where the view of those lights are no longer present. The side of the bus, at least the ones near me, if you're on the side of the bus and it starts running its amber lights, you won't see them. Yes, you're in the bus's blind spot, but you're also in what I call their signals blind spot. And there's a point on the approach to the bumper of the bus where those top yellow flashing lights will be yellow. Then there's a point where your central vision will divert off those yellow lights to look for hazards ahead. and you're going to enter into a blind area. Here is an example that I did the other day when I was driving. I came across an intersection. It was set up similar to this one, where you have, I had to make a left-hand turn, and you've got usually a turn signal, and you've got the little arrow that says turn only, and then on the other side of the boom, where the blue circle is, you have a street sign. So we were stopped. I had a few minutes, so I looked up, I read the turn only sign, and then I drew my attention over to the street sign. I read the words on the street sign. I'm like, okay, let's see if I can read the turn only and the street sign at the same time. So when I refocused my vision, my center vision, back onto the turn only, I couldn't read the words of the blue sign. In fact, the blue was just kind of a little blip in my field of vision. So try that on your own if you have them in or not. It kind of really puts things into perspective again. But also remember, you're stationary. You're not going 25, 35, 45 miles an hour where your fields of vision are constantly changing. You know, your environment's constantly changing. Cars are coming in and out. So hopefully this puts a little more clarity into the previous slides.